A strong country often comes out ahead because it has good schools and great scientists. Even in the time of the American Revolution, people knew this and respected the great schools many scientists called home. Many of these schools had telescopes to look at the stars, the planets, and other things like comets. Big pieces of rock moving through space can be hard to find, so scientists and math people shared information to know where to look for them, to know where to point their telescopes. After the American Revolution, France had a French Revolution of their own. The city of Paris went through many changes, shuffling the teams of scientists with good jobs, so some old ones were out and some new ones were in. The fighting general Napoleon became the man in charge of France. This changed around who was on what team of scientists, and also the teams at French schools. It all changed even more, especially because Napoleon took science seriously. In the year 1801, Napoleon honored the Italian scientist Alessandro Volta, who invented the first battery machine. By putting one kind of pure metal next to a different kind, like cookies mixed in a row, one then the other kind, electricity was first able to be stored in Volta's machine. People already knew living bodies had electricity in them because of Volta's fellow Italian Galvani. But this machine, the battery, did what Ben Franklin's kite could not do. A battery can store electricity for a long time. Scientists all over the world began to experiment with them. It is a good question which of the two men did the most to change the world. Was it Napoleon or Volta? Volta explained his battery to scientists in Paris. But Napoleon brought all those scientists together and helped them do their work. A boy in London fell in love with the kind of science shows people made. Volta's demonstration in Paris was an example. These were mostly long talks, but sometimes showed experiments too. This boy's name was Michael Faraday, and we can try to see this world of the past through his eyes. He wanted to be a scientist. He succeeded. He never knew much math, so it was his great experiments that helped everyone learn about electricity and magnetism and how they seem to go together. Nobody understood how this worked, and the way they are a pair is amazing even today. Young Michael found himself fascinated by lectures on science in London. Like many of the city's people, he went to the talks and shows and learned to write down good notes about what scientists said. Later, he grew to be more useful, especially learning to clean up a lab. Like many in London, he had met great people at these talks. He ended up getting a job helping Humphrey Davy, cleaning his lab and being his personal servant when Davy traveled Europe. Michael had completed his teenage years of study as an apprentice, working in a bookshop, putting the covers on books. He studied for years in his spare time, before getting his job cleaning up for Humphrey Davy. Michael missed out on going to school or learning real math. His experiments as a grown man were among the most important in the history of electricity. That hard-working scientist grew up in a London that was excited about science. In 1807 and 1808, Davy found many pure metals. These did not break down when mixed with other things. Something like table salt actually breaks down into two of these kinds of pure things. They grip each other with the magnetic power that goes along with electricity in a wondrous way. Volta's battery made it possible to tease this grip apart, separating the pure things from their mixtures. For example, we don't just breathe oxygen, it also sticks to things in rocks. The electric battery made it easier to get the oxygen in rocky mixtures to let go of the things it was sticking to, magnetically. More properly, thanks to a friend pointing this out, electrically. Faraday became part of Davy's team in England. In the 1820s, teams in Denmark and Sweden made great progress too, also thanks to the assistance of Volta's battery. In Sweden, Jacob Berzelius was the best-known face for his team that uncovered the essence of sand, as well as the metal used in aluminum foil, the shiny stuff people wrap food with sometimes. The first of two other things Berzelius did was use the first letters of these pure things' names, like O, for oxygen, and he used these to write formulas for chemical reactions. Another thing he did, which was helpful to other scientists, was to carefully weigh these different kinds of things in rocks, including metals and mixtures. This helped the other scientists check that their scales produced the same numbers, weights everyone could rely on. Another team, in Denmark, was led by Hans Christian Ørsted, whose name begins with a Danish kind of O that is different, and who was also friends with Hans Christian Andersen, the author of fairy tales. Ørsted's work with aluminum stood out too. In one of his lectures in 1820, a surprise showed a new direction for scientific research. While demonstrating a battery that could be turned on or off, Ørsted and his students were surprised to discover that the needle of a compass would move if it was nearby when the battery was switched on. The question of how this worked was a new, important question. After a few years went by, young Faraday became the man whose experiments first explored this magnetic action more than any other. Electricity had separated things inside rocks from each other, but an electric battery also spread some kind of energy across a distance that was seemingly empty, except for air.